Hi, my name is Mel, and I'm going to talk a bit about computer storage. I've covered this before. I want to go over it again, and I'm going to cover this sort of basically. So computer storage holds your data. Okay, so there's RAM, which is temporary, is ultra fast, and it's volatile, so loses data without power. Connects directly to the CPU. Now you need RAM to run anything on any computer because it's where it loads its programs, its files, everything. Okay, applications, everything. You need RAM. And if you want your computer to run faster and more capacity, you are going to need more RAM. There's secondary storage, like a drive, like permanent, slower, non-volatile, so retains data without power and holds the operating system and files, okay? So there are some modern storage technologies. So the solid state drives, SSDs, use flash memory chips with no moving parts, making them fast and durable. How they work? They have what's called a floating gate or charge trap. Transistors trap electrons to represent bits, ones and zeros. They have NAND, NAND, flash types. Different types are single level cell, multi level cell, triple level cell, quad level cell, and all that sort of stuff. Wear and tear. So SSD cells degrade every time data is erased and rewritten. This is measured in TBW or terabytes written. Okay, so SSDs can become corrupted and virtually useless after a certain amount of use. Hard disk drives are mechanical drives that it can be used and are used primarily for cheap high capacity archiving. And how they work is magnetic platters spin at high speeds, usually 5,400 or 7,200 RPM, while a mechanical arm reads and writes mechanically. So they use magnets to read this magnetic field. So the downsides of a hard disk drive is one, they are slower, much slower. They're susceptible to physical shock, much higher power consumption. And the speed of a storage device depends on how heavily it depends heavily on how it connects to the motherboard, right? And in what ways. So there's what's called SATA or serial ATA, which is older interface designed for HDDs. And they moves around 550 to 600 megabits per second and used by 2.5-inch SSDs and traditional hard drives. NV, NVMs or non-volatile memory express, a modern protocol built specifically for flash storage, allows the drive to draw directly to CPU via PCIe lanes. M2, a slim gum stick form factor. M2 drives use either slower SATA protocol or ultra-fast NVMe protocol. So, key performance metrics. So, when evaluating storage, you got to look just beyond capacity, which is gigabytes or terabytes or petabytes. If that's coming, it probably will. Sequential read write, speed of moving large single files, rendering like, a 4K video, modern PCIe Gen 4/5 NVM SSDs they do that better. Random read write, as they're called, speed of handling thousands of tiny scattered files, like booting an operating system or loading a game. That's something else again. And latency, the time delay between a data request and transfer starting. SSDs have near zero latency, and HDDs will suffer from mechanical delay. There's also like cloud storage and tape storage. I'll go to that in a bit. So, how does the file system organize data? So the operating systems all operating systems use a file system. So like NTFS for Windows, APFS for Mac, or ext4 for Linux to create a directory structure. Partitioning. So dividing a single physical drive into multiple logical, so C, D, E, whatever, fragmentation. Hard disk drives scatter file pieces across the platter over time. It just happens, slowing down access. SSDs do not suffer from performance loss due to physical fragmentation, but they use trim commands to wipe deleted blocks in the background to maintain write speeds. So that's just so. Look, I would often recommend that people use a combination of both. They have a HDD, but also have an SSD, because usually can have larger hard drives for some purposes, and like hard disk drives, HDDs can come in higher storage capacities than SSDs currently do, and that might change down the future and probably will. But I would use a combination of both. All right, you want an SSD for fast options for when you need it, and you want hard disk drive storage for when you need it for other things. Okay, but sort of more long-term storage and backups require different strategies than daily use storage. So daily storage prioritizes speed, while long-term storage prioritizes data longevity, preventing what they call bit rot and redundancy, so surviving some sort of hardware failure. So look, the core strategy that most people would be recommended, and I think you should do this, is 3-2-1 backup rule. 3 copies. Keep 1 primary working copy and at least 2 backup copies. 2 different media, 2 different types of storage technology, internal SSD and an external LTO tape, or mechanical HDD or network storage device attached, or cloud storage, to protect against any manufacturer defects or specific hardware vulnerability. 1 offsite location. Keep 1 copy in a physically separate location, cloud storage, or a safe in a different building to survive thefts, floods, or theft. And you should do backups regularly, at least weekly. All right, because if you're going to need to recover your systems and data after something goes wrong, then you are going to need them to be up to date as possible. Okay, so, and as I was saying, so long-term media lifespans and vulnerabilities. So there's magnetic tape, or as they call it, LTO. Rated lifespan is from about 15 to 30 years. And its vulnerability is humidity and magnetic fields. So, best use case would be enterprise archiving. To store them and to record them, you would need hopefully a space that's got low humidity and shielded from magnetic interference. Okay. Enterprise hard disk drives, about 3 to 5 years active, if they're active. Mechanical seizure, lube dry out. Best use case would be network attached storage or cold storage arrays. Consumer SSDs, 1 to 3 years unpowered. They have charge leakage, loses data. Daily backups, not archival. Cloud tier. And there's different, obviously the lifespan's going to change on what you get, but that's very high in cost generally. Provider bankruptcy, that could be an issue. Subscription costs are high. Provider could go bankrupt. Off-science compliance backups, they could be all sorts of problems. Now, what about USBs? Having unpowered USBs stored is not generally a good idea, because they will lose their coherence and they can be lost and stolen and broken and all sorts of stuff. Wouldn't even leave them plugged in, and USBs can be interfered. Now, USBs, if you're transferring files from one place to another, from work to home, make sure you've got permission, or you're transferring or need storage for a particular thing, temporarily. USBs can be quite good. Okay, but just be aware that there are problems related to USBs. And not saying they're bad, but just be aware. So the go is there's no storage solution that's completely safe and without risk, and that or don't have a lifespan. And this is something that you need to sort of come to grips with, because you could have legal regulations that's saying its data has to be kept for a certain amount of years. So you would definitely look at be archiving in some method, or methods probably in plural, like tape and storage in cold storage, and maybe optical disc. Although that can, like undamaged, last up to 1,000 years, but they suffer from physical scratching. Like permanent families documents, family photos or documents might be that, or sometimes, like M-Disk. I mean, I think you could use it for some storage, but you got to be very careful. You label them clearly and protect them, and don't use them unless you need to. You could get, the optical discs is another option that could be looked at. The SSD danger zone. Never use SSDs or USB flash drives for long-term cold storage in a drawer. Flash memory relies on trapped electrical charges. So this is USB as well. Without power, these charges gradually leak out and over 12 to 24 months, resulting in unrecoverable data corruption. So, I mean, that is just a fact. So I'm saying, be very careful about USB. I mean, like, not saying don't use it. Just be aware that don't just, store something and stick it in a drawer and hope to be fine. Store it, label the USB. If you're going to store it, don't store it for any more than a couple of months. Frequently USBs can be, if they're high speed USBs, they can be useful for having some programs or stuff on there that you don't use every day but might use like once a week. It can be good for that, because they're constantly being plugged in and being charged. Then they're not going to last forever. Obviously not. That's not going to happen. I mean, like, look, how long they'll last is going to be best guess maybe 1 to 3 years. I mean, but like, it really is going to depend. All right. So I am saying this is like, in terms of computer storage, this is something that you really need to think through. What you need to store, what risks does the storage, like how, if this information gets out, or if it gets damaged, if it gets stolen, blah, 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 if it gets corrupted, who's going to have access to it, and how's it going to be stored, where's it going to be stored, and how safely can you store it, all that sort of stuff needs, and should it be stored is another thing too, because like, certainly a lot of people and places have legal requirements to store information, but you've also got to make sure that any information that is stored is encrypted. If it's being stored, it's encrypted at rest. You should install data. So data at rest and in transit. You should store like encrypted at both. So transit means obviously in transmission. Stored is when it's been stored. So encrypt it highly. If you're going to have physical devices, like you have them in a very secure, away from the main building place that's secure, with biometric controls that have got, humidity and magnetic field reduction, like fire suppression, blah, 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 or the whole box and dice, as best you can, So linear tape open, or LTO, or magnetic tape, remains the gold standard currently for massive data archives. How it works is data is written sequentially into spools of magnetic tape. Look, the pros of it is its lowest cost per terabyte, completely immune to sub-attacks when stored on a shelf, like air-gapped. Cons, extremely high upfront cost for the tape drive reader, slow sequential access times. Cloud storage, services like AWS Amazon or Azure Archive offer relatively low cost storage. You upload the data to the cloud, and the provider stores it on massive tapes or hard disk drive arrays. The catch? The storage is cheap, or cheap-ish, but retrieval is expensive and slow, and it can take 1 to 12 hours or more to download your files if you need them. And I mean, like, also too, like terabyte, like there's usually billed on terabyte per month. But it can be billed differently, and you would need to look at that. Preventing bit rot, data degradation. Bit rot occurs when magnetic fields flip or electrical charges fade, silently corrupting random bits of data without throwing an error. So checksums. Generating a unique cryptographic fingerprint like SHA-256 for a file. If the file changes by even 1 bit, the checksum changes, alerting you to corruption. Self-healing file systems, or ZFS. Used in network-attached storage devices that continuously read data in the background, check it against parity data, and automatically repair any corrupted bits on the fly. And listen, all of these, if you're looking at computer storage, like for personal or business or whatever, these are all things. Now, for most people, like getting a hard disk drive or SSD, I would recommend getting both. Would be that you can get lower in volume in terms of how much they store. They still cost, but you look at how much you need to look at the cost because they're not cheap. But there are options there. Now, for businesses that need as well as that, or for people who need well of that, then you've got to start looking at, you can get a certain amount, like Google has a certain amount of personal storage you can do for free. You've got like a certain amount of Microsoft storage for free too, if you have a Microsoft account. Beyond that, you have to start paying. And there are some free, like file storage, debating on how good they are. But look, that is something you need to look at, is price cost depending on what you need stored. So, like, if you're a person or persons for whatever reason needs to keep this information, like digital information, secure, then you're going to need to look at all the components of how do these, like what is the cost? What care do you need to take care of them? And as in, like protect the information for yourself and for others, and what maintenance you might need to do. Like, because every so often you are going to have to plug in the USB, at least once a week to probably, and they're not going to last more than 1 to 3 years. So you need to copy the information off probably within a year to another USB. Okay, or to another drive. And I mean, and that's just the way it is. Magnetic tapes don't last forever too. They have to constantly copy information from one tape to another, or from one hard drive to another, or one SSD to another. Okay, so no storage is going to, like, it's all at risk from damage or corruptions. It's all at risk for security. So that's something that you need to think about. Okay, I hope this helps. This is just talking about computer storage. It's fairly basic, but we're sort of I'm trying to give people sort of like a bit of a, what should I think about and why should I think about it? All right, thanks.